The 20th century witnessed some tremendous advances in the development of science and technology. This was particularly so in regard to astrophysics and the fine-tuning of the universe. When Albert Einstein developed the general theory of relativity in 1915, he believed that the universe was static. However, this later proved not to be the case, and 12 years later, in 1927, Father George Lemaitre, a Catholic priest and physicist, proved by the mathematics of general relativity that the universe was in fact expanding. This was confirmed 2 years later by the astronomer Edwin Hubble. In 1931, Father Lemaitre went further to show that the universe began with a primeval atom nearly 14 billion years ago. This primeval atom is now known as the Big Bang, and future scientists would confirm the accuracy of Lemaitre's analysis. It is now an accepted scientific fact that the universe began 13.7 billion years ago. So the Big Bang presented a real problem for scientists in that if the universe had a beginning, it had to have a beginner or creator. However, it's not just the beginning of the universe that's a problem. There's also the extreme accuracy of the physical constants of the universe. Today we look at just two of these constants, which had to be extremely accurately fine-tuned in order to allow the universe to exist. The explosive energy, which started with the Big Bang, is known as the cosmological constant. It needs to be accurate to less than 1/1,000,000th of a second. If it was, say, just 1/1,000,000th of a second faster, it would have blown the entire universe apart so rapidly that no galaxies, no stars or planets could be formed. On the other hand, if the expansion rate was slightly less, even by 1/1,000,000th of a second, the gravitational pull of the universe would have caused the entire universe to collapse back on itself. The same kind of absolute accuracy can be found in another branch of science known as quantum mechanics. Here we are dealing with things on an extremely small scale, inside the atom. Atoms are extremely small. There are trillions of them in a single speck of material, say a particle of dust. Protons inside the atom are positively charged and therefore repel each other. The strong nuclear force overpowers this repulsion by the protons and therefore maintains the stability of the atom. This force is billions of times more powerful than gravity. However, it also needs to be precisely fine-tuned in terms of its strength. For instance, if it was 1/1,000,000th of a percent weaker, the protons would fly apart, causing the atom to disintegrate. This would mean that there'd be no matter of any kind formed. This in turn would mean there'd be no planets, no stars, no galaxies, in fact, no universe. Once again, modern science has shown the extreme accuracy required to engineer the universe and the infinite intelligence behind it. So these are just two of about 24, 25 known physical constants which are essential for the existence of the universe to exist. However, there are also several features unique to the planet Earth which are necessary for the creation of life here. Here to just take two examples. First of all, the effect of the Moon and also the planet Jupiter. The gravitational pull of the Moon helps to stabilize the orbit of the planet Earth around the Sun and to maintain the correct tilt towards it. Without the Moon's gravitational pull, in fact, the Earth's tilt would vary wildly over time due to various different things like the gravitational interactions with other planets. The Moon, therefore, basically helps to maintain moderate weather, predictable seasons, and it also impacts on sea tides and marine life. The planet Jupiter also plays a vital role in protecting the Earth. Jupiter is about 1,300 times the size of the Earth, so its immense gravitational power means that the Earth is shielded from the millions of asteroids flying about in space. So these are just two of the several unique features that make life possible on Earth. In fact, many physicists such as Stephen Meyer say that despite the fact that there are trillions of stars and planets in the universe, it may not be unreasonable to assume that the planet Earth may be the only planet capable of supporting life. So the Earth has in fact a whole range of unique features, and it's also in a unique position within our galaxy, which is absolutely vital for the support of life on Earth. However, despite this evidence, there are still atheists who hold on to the old atheistic view and create publicity for themselves on that basis. Some of them are also fanatical in their thinking and maintain views that formed as teenagers, despite huge mounting evidence to the contrary ever since. One such scientist is physicist Lawrence Krauss from the United States. In 2012, he wrote a book called A Universe from Nothing. In recent decades, modern science has confirmed that the universe had a beginning, which means that it had to have a creator. However, Krauss disagrees with this analysis. He claims it jumped into existence all on its own, that it came from nothing. In order to justify this daft claim, he first of all changes the meaning of nothing to mean very small spaces, quantum particles inside an atom. These particles, he claims, can go in and out of existence on their own. And on that flimsy basis, he develops an idea that the universe could have come into existence from nothing. However, what he fails to take on board is that the quantum space, the time, and the laws of physics that he talks about are all a product of the existing universe. So he's not actually starting from nothing at all. I think you've just seen that Dawkins had made a fortune from pretending that atheism had some sort of a scientific basis a few years earlier. But the idea that you can develop a theory of starting a universe from a few particles in an atom is basically just as silly as Dawkins trying to claim that God is not real unless you can prove him by science. Krauss claims that mathematics and physics point towards the idea of a universe coming from nothing. It is very interesting in its own way. This is very much in line with Catholic teaching. The Catholic Church has always thought that the universe came from nothing, was created by God, even when science claimed that it always existed. So it's ironic that one of the world's best-known atheists has helped to confirm the truth of the Church's position in this regard. So the discovery that the universe had a beginning, it really forced scientists to claim that the universe could begin on its own. However, they basically tried to claim that, but in doing so, they found themselves pointing towards a creator, even if that was not their intention. Here now is a clip from Dawkins and Krauss talking about evolution and the universe and all that sort of thing.
Of course it's counterintuitive that you can get something from nothing. Of course common sense doesn't allow you to get something from nothing. That's why it's interesting. It's got to be interesting in order to give rise to the universe at all. Something pretty mysterious had to give rise to the origin of the universe. It's exactly what's meant by nothing, but whatever it is, it's very, very simple. And why is that funny?
Well, I think it's a bit funny to be trying to define nothing.
Richard Dawkins, I'm sure he didn't say that. That seems ridiculous.
Question of something from nothing. As it happens in the case, as I think we've talked about before, in biology. I mean, how do you get life from non-life? That was originally sort of the main theological question. How do you get life from non-life?
But that's a much easier problem in a way, because you're starting with chemistry. You start from molecules bumbling around in the warm little pond, as Darwin called it, primeval soup, as people later called it. And then you get the first self-replicating molecule. But something from nothing, from literally nothing, and that's what really gets people. That's the one that's really counter to common sense. And they clearly misunderstand what you mean by nothing. So
well, exactly. And something and nothing are not theological or philosophical quantities. They're physical quantities. Most people recognize that something is a physical quantity, but they refuse to accept the idea that nothing might be a physical quantity. It's a remarkable and unexpected thing you can imagine, that you could start with absolutely nothing. That means, unlike the cardinal said, and unlike some people argue, no particles, but not even empty space. No space whatsoever. And maybe even no laws governing that space. And we can plausibly understand how you could arrive without any miracles, without any need for a creator, without any supernatural creation, you could produce everything we see. And I find that the fact that it's plausible, remarkable, in the same sense that I think I found it plausible when I first learned about evolution. The amazing fact that the diversity of life on Earth, which seems so designed and complex, could arise from so simple a beginning.
these two things are both extraordinarily exciting, intriguing, enthralling. Clearly life is, clearly the idea that you can start with nothing but chemistry, the ordinary laws of chemistry, and end up with us and kangaroos and oak trees and wombats. I mean, that is the most astonishing fact. But you know, even more astonishing is that you can get physics, you can get matter, you can get everything from nothing.
Okay, so that's it for today. Thank you very much for watching, and please subscribe to the channel. Just to say, in relation to what those two guys were talking about, a universe from nothing, that's not a possibility. It never could happen. It's all nonsense. But it's fine. It's science fiction, basically, and the idea too that Dawkins talked about, of course, like that non-life developing into life. That's not true either. There's no evidence whatsoever, and there never will be any evidence that a situation of non-life could develop into a cell. The cell is extremely complex. Dawkins knows that perfectly well. The actual, I'll deal with that in a week or two, the actual idea of the complexity of the cell. So if you'd like to see that, please subscribe. And for today, thank you very much for watching. Goodbye.